Hello. In this video, we will be covering the EMP cooling system. Details specific to your system are available in the System Service Manual. The manual will include information such as system fan speeds, current consumption, fusing, EMP link layouts, and schematics. These can be obtained via our website under Product Documentation, which is covered in more detail in another video. There are four major components that make up the system. The first major component is the Thermal Management Controller, also known as the TMC. This is the module that communicates with the application it is on and controls other controllers attached to it. The second major component are the FIL fans. There can be any number of fans on the system, all receiving their commands from the TMC. The fans come in two sizes, 11-inch or 15-inch, pusher or pullers, which is the direction of the airflow, and voltages, which can be found in the service manual. The third major component is the harness. This will tie the TMC to the vehicle's J1939 CAN network and the fans to the TMC via our EMP link network. The schematic of the harness can be found on the last two pages of the service manual. The fourth major component is the shroud. All physical hardware of the system attached to it, such as the power and ground studs, harness, fans, and TMC. It will also have mounting points to be attached to the vehicle or application it is cooling. The system is typically on a dedicated circuit fused to the appropriate amperage for the system. The system will have live power until the disconnect is switched to the off position. It may be getting its power from either batteries or a DC converter. Fuse size can be found in the service manual. The ignition is required to wake up all the controllers on the system and acts as the on-off switch. Ignition will be a switch source and on a different circuit than the supplied power of the system. The TMC is the brains of the operation, capable of maintaining temperatures independent of vehicle or engine speed. It will be communicating on the vehicle's J1939 CAN network. It will typically be monitoring vehicle temperature sensors, but it can also monitor external sensors wired directly to it. The TMC will be programmed with specific calibrations tailored for the vehicle it is cooling. This will let the TMC know the temperature set points and will then use that information to command the fans via EMP link to maintain optimal temperatures for the vehicle. The TMC also has diagnostic capabilities and is OBD compliant. If there are active diagnostic codes, it will blink the code out on a diagnostic lamp near the system or in the engine compartment. The system can interface with the EMP service suite, which will allow you to communicate directly to the system. This will allow you to manually command fans, view diagnostic codes, access the troubleshooting manual, pull history, and other various action. You can also connect to the system via EMP Mobile, which is available on your phone app store. This will allow you to view fault codes, clear codes, and pull history and email the file directly to EMP. The service suite is explained in greater detail in our other videos. The system will be comprised of a fan or many fans, depending on the cooling needs of the vehicle. Each fan will have an internal controller and will be commanded by the TMC. If a fan ever loses communication with the TMC, it will spin to a default speed that is set by its calibration. The fans on the system with the same part number are interchangeable. This will aid in diagnosing the system if you suspect a problem with a fan. For example, if fans 1 and 2 are the same part number and fan 1 is not operating while fan 2 is, we can swap the fan locations and see if the behavior is following the fan or specific to the location. The fans utilizing address resistance to determine their location on the system. This is determined by reading the resistance value from the harness location it is connected to. There are two EMP link channels the fans are connected to. The odd number fans will be on channel 1, and the even number fans will be on channel 2. This is to decrease the amount of resistance values needed for specific locations. Please note, older systems may only have one EMP link channel. Fan layouts and address resistances can be found in the service manual. A cooling system schematic can be found in the service manual. This will show you the I/O of the system, fan reverse diagnostic lamp, vehicle J1939, ignition, power and ground. It will also show you the fans and their locations numbered left to right on the system and what EMP link channel they are on. As we can see from the schematic, EMP link 1 in red connects all the odd number fans to the TMC, and EMP Link 2, in blue, connects all the even number fans to the TMC. If there are any active diagnostic codes, the TMC will blink the fault codes on the diagnostic lamp and is usually located in the engine compartment near the system. The notification lamp is an optional lamp located near the operator. If an active code has been active for a predetermined set amount of time, it will illuminate solid on to alert the operator to notify service. A service technician can place the system into maintenance mode to have the notification and diagnostic lamps blink all active and pending codes. When a code is present, it is recommended to connect to the system via the EMP service tool to get more detailed information on the codes. This is covered in more detail in our other videos. The fan reverse push button is a momentary contact push button. This means it needs to be pressed, then immediately let go to initiate the reverse cycle. To force a reverse cycle to end, simply press the reverse button again. OEM installations may use a momentary toggle instead of the push button to activate or exit the reverse cycle. This button is also used to enter and exit maintenance mode by pressing and releasing 4 times in 2 seconds. Depending on the calibration in the TMC, if the push button or switch is held instead of immediately released, it may result in full speed forward fan activation and will stop when the switch is released. Ensure you press or toggle and release immediately to activate the reverse feature. If you need to confirm the operation of the fans for diagnosing the system, there are 2 ways to accomplish this. For systems without maintenance mode, initiate a reverse cycle. After the cycle ends, the fans will sequentially start up at a slow speed forward to allow you visually see them operating. If your fans do not end the reverse cycle with a fan forward operation, attempt to enter maintenance mode. Maintenance mode was introduced in 2020. Enter maintenance mode by pressing or toggling the fan reverse switch 4 times in rapid succession. When the system enters maintenance mode, the fans will sequentially start up at a slow speed forward and stay on for the duration of maintenance mode. Maintenance mode was introduced in 2020 to aid in investigating abnormal behavior and troubleshooting the system. As stated in previous slides, maintenance mode can be entered or exited by pressing or toggling the reverse switch 4 times in rapid succession. When you think you have repaired an issue and need to clear the codes, ensure at least 1 ignition cycle occurs following the repair, then check for pending codes via maintenance mode or the EMP service tool. Recommended maintenance intervals were released in a service bulletin and can be obtained from our website under product documentation. Enter the document number referenced in the title of the slide in the search field to find the document. This will have a table for routine maintenance ranging from daily to annually. It will also have both the approved types and quantities of dielectric grease for each connector. When replacing parts on a system, it is important to apply dielectric grease to the appropriate connectors. This will maintain the connector integrity and prevent corrosion. The amount of grease to use per connector is listed in the grease quantities table of the recommended maintenance service bulletin or the service manual of the system. The cleanliness of the heat exchangers is very important. If they get clogged with debris or road treatments, it will impede its capability of pulling heat from the coolant. To maintain the heat exchangers, use the reverse cycle after every washing to push out loosened debris. The heat exchangers should be pressure washed every 3 months or more often if your area uses salt or surface treatments. You will then need to wash them as often as needed. To avoid damaging the cores during pressure washing, the washer should be set to no more than 1200 psi and must stay at least 9 inches from the fins on the engine compartment side and at least 12 inches from the system on the exterior side. Cleaning solutions shall be safe on aluminum to prevent corrosion, effective on grime, and effective on salt surface treatments in use in your area. Always activate a reverse cycle after each wash. If you have any additional questions or need assistance, feel free to contact us at service@emp-corp.com.